thanks a lot for organizing that, Manfred and Barents. It's great. And so it's my pleasure to introduce Fuad Aleskerov from the Higher School of Economics in Moscow. And he is a distinguished professor of economics with a focus on decision theory and, and social choice. And of course, he has published extensively articles and books on a wide range of topics, including power analysis and multi-criteria aggregation rules, threshold aggregation, also historical topics in social choice, as the one Manfred mentioned already, and network analysis, I guess, in more recent years. So I first met Fuad even before I graduated at the very first conference that I ever participated in. That was the Voting Power and Procedures workshop at the University of Warwick in 2006, I guess. And so he was one of the very first scientists I ever met beyond my own degree program. And I was lucky enough to be invited to the Higher School of Economics in Moscow and also in Nizhny Novgorod, and I have very good memories of that and remember all the pleasant conversations we had there and at other conferences, and I sincerely hope that we can meet again in the not so distant future. So nowadays I'm based in Denmark, which is one of the Arctic countries, so leading over to the topic of Fuad's talk today. It's one of the Arctic countries, at least as long as Donald Trump in his second term to come soon has not yet purchased Greenland. Actually, Donald Trump allegedly also had the idea of swapping Puerto Rico for Greenland a few years ago. So we'll see. And with that, I leave the floor to you, Fuad.
Thank you very much. Thank you very much indeed. First of all, Manfred, thank you for the invitation, and thank you, Michaela, for your warm words. For me, it is, you see, I would like to say one thing. You see, first time I was in the States in 1985. In 1984, Soviet Union shut down this Korean Boeing, maybe you remember this, and Reagan said that the Soviet Union is the empire of evil, and forbid all kind of direct flights from Soviet Union to America. And we went through Havana, Mexico City, LA, passed several universities, we gave talks in several universities, came to Montreal, and then came back to Moscow. And I remember very well my teacher, Mark Eiserman. He was worried, and naturally I was worried about how would be the meeting, you see, because under these circumstances, we didn't know, and it was the warmest meeting I had at that time, because you see the discussion was, well, the words were that we are the family of scientists. Politics is politics, but we are the family of scientists, and we are the family over all world. And this was really very supportive. Unfortunately, we again came to some darkness, as you know, and I don't know what will be next. I signed several letters. We have censorship now, and for wrong interpretation of the events, it is possible to be imprisoned for up to 10 years. Can you imagine? For wrong interpretation. Okay, but again, we are the family of, we are a family, and let me talk about this very interesting topic. I started to work a few years ago, 4 or 5 years ago, concerning Arctic. And thank you very much again, and I will proceed. The story of this topic was very interesting. My rector asked me to join the seminar on Arctic, and I found it rather impolite to tell him that I am not very interested. I am not at all interested with Arctic, and I said, okay, I will come. I came there. I sat 20 minutes listening to these words, etc., and then I took out my block note, which I always go with, and construct the models. And my students and colleagues joined me. These are my co-authors. Last year was 2 years ago was published one article on this topic. Can you see? I changed the screen. Can you see it? Excuse me. Can you hear me?
Yes.
Yes.
And can you see the change of the screen?
Yes,
Yeah,
it's the outline slide now.
Great, great. Okay, you see, sometimes in Zoom it doesn't work. So I would like to talk about several topics. You see, when I didn't write it here, it is about the analysis of disputable zones in Arctic and how to allocate these zones, and then maybe to tell a few words about ecology, which is also a very important part of the story. And this is the Arctic region. The view from the top, we never use this, and this is my my student, Elizaveta Viktorova, found this picture. Even after this 5 years of work, it is very unusual for me to look at this way. And the story started a few years ago when they found gas and oil mining reserves in Arctic. Today they say that the 30% of oil reserves of the Earth and a bit less, but still they say it's 25% of reserves of gas are concentrated in Arctic. After that, immediately there were words about that we should exploit it, etc. And this is the map with the distribution of oil and gas here. And then you see many countries reflect their interest to Arctic zones, and there are, let's say, some words now that Arctic belongs to all mankind, so we should split it equally among all countries, etc. So I think that the tension around Arctic will increase next 20 years, and especially, you see, why it is the case, because the ice in Arctic began to melt. And this makes the excavation of this oil and gas much easier than before. And then I constructed a model of how to, let's say, allocate these zones or disputable zones among countries, among interested countries. But in the article, and I gave a few talks about it in Arctic congresses, plenary talks, I always emphasize that, you see, we're mathematicians. I'm a mathematician. I don't allocate territories. What I can do, I can construct a mechanism to solve this problem instead of war, instead of tension between countries, rather by some kind of models which provide maybe some kind of, let's say, fair allocation in some sense. And so we discussed about this gas and oil first of all. Next, these are natural resources. Fish is located in this Arctic region. For some countries, it is a very serious part of their economy. And finally, we have sea routes. Sea routes which goes through to Europe, around America. And I would like to say here that the importance of these routes are becoming more and more high because of the, you know, that because of the pirates in southern seas, especially in south of Africa, the insurance is growing up, you see, and so many countries now consider this pass through not around Africa, but rather through these north passages. There is a northern sea route and northwest passage, so-called. And then these are countries under consideration. And it is interesting that many countries really revealed their interest, show their interest in this very topic. Naturally, among them is Denmark, Greenland, Canada, USA, Russia, but we also have there China, Japan, South Korea, even Australia also told few words about this very fair allocation of Arctic territories. First of all, I would like to tell you how it is organized, Arctic zones are organized. For 5 Arctic states, they are written here, Canada, Denmark, Norway, Russia, and the United States. There are exclusive economic zones which are equal to 200 nautical miles, and it gives exclusive rights to excavate all kind of resources to do whatever they wish in these very exclusive economic zones. Okay, and the sea beyond these very zones are considered, so they are called the high seas or international waters, and they are not owned by any country. And so today, if we follow United Nations organizations rules, we cannot allocate these very territories inside these exclusive economic zones. We might only go and consider high seas, okay? Okay, this is the so-called, these are exclusive economic zones in Arctic Ocean. This is this very picture. And what are these very zones, high seas, I mean? So the one is called Loop Sea or Banana Hole. It is between Norway, Iceland, and Faroe Islands and Greenland, 250,000 square kilometers. Another one between Norway and Russia, and it was, there were rather, I cannot say tension, but some kind of tension, which was resolved, and we will talk about it later. In 2010, it is around 175,000 square kilometers, and north of Arctic is 2,800,000 square kilometers. Please interrupt me if you have any question, any moment, okay? These are these very territories which we can discuss concerning this allocation problem. And the total number of areas, what I did in this very model was the following. You see, first of all, to split all these high seas to some kind of small regions, you see, small areas, and we did it. So it is 800 to 800 meters. This is such kind of thing is 640,000 areas. with natural resources are 59 plus thousand kilometers, areas, and not in exclusive economic zones, only 9,000. And this is the very idea which I constructed at that very time when I first heard about it. You see, the idea of the model is very, very simple. Look over here. Inside this exclusive economic zone, I have a full utility, full my, let's say, preference, which is equal to 1 in this territory, in this very zone, okay? And then my interest to this to some area is declining depending on the distance, okay? If I am living in the west of, let's say, in Norway, my interest to some territories in Chukchi Sea, because it is far away, is really much smaller than my interest, which is in the European part, for instance. And this D star was taken as 4,000 miles. Okay, so we have a full interest in this exclusive economic zone, and then the declining function of utility to these very zones outside of my exclusive economic zone, up to 4,000 miles. After 4,000 miles, I don't have any interest. You see, my interest is equal to 0. It is for oil. The same story is for gas. The same story is for fish, okay? And only marine routes are evaluated in a bit different way. They are evaluated with respect to my activity on the sea, okay? If I have a lot of volume of cargo to be transported from my country to another country, then I am interested with this very routes more than other country which does not have any interest or very low interest to some export-import operations. So that was the model itself. And first publication was in, as you can see, about this very model in 2015. Elizaveta Viktorova at that time was my student of an even undergrad student. She collected all data and we made some evaluations. And the story, first of all, the story was the following. You see, we tried to aggregate our preferences over these territories since we have different kind of preferences over gas, oil, fish, and maritime routes. We had to aggregate them, and this is the story about aggregation. And finally, we have this ranks of, you see, these are 4 parameters, you see, and finally we have these ranks over all territories. And this is, if we might introduce some kind of parameter which tells us about the interest of country in natural resources, you see. And here we have this very disputable zones, you see. And this is, you see this red story, red areas are the highest conflict, highest overlapping of interests. And then we started to construct the model of allocation of these disputable zones among countries. And we did several models. The first model was this one, you see. if I get some territory out of this allocated territories, and it is in the zone of my interest, I have some utility, right? If I don't get it, this is the left part of this functional. If I don't get it, this is minus, you see, I don't get it, so I'm disappointed. And the idea is the total satisfaction level is defined by this, and the functional is, the goal function is to decrease the dissatisfaction level. That's all. This is one of the ways how to do it. And then this was algorithm was constructed, and the guys, my students again, you see, they did some work. They constructed, they wrote a software, and the idea was very simple. You see, the first one, for instance, we studied and did some scenarios of our work, of our allocation. First of all, for instance, all areas of Arctic region are allocated to the closest country, okay? Then we try to reallocate it, trying to decrease this dissatisfaction level. Second scenario, we give everything in a very random way, again, then reallocate. Third scenario, we give these territories to most interested in terms of their utility countries, etc. So we have 12 allocations, and criteria to terminate the exchange procedure. As I told you, there is an exchange procedure. After we allocate somehow, we start to exchange procedures, and the criteria to terminate is either maximization of total satisfaction level, so we cannot do it better, or maximization of satisfaction levels for most unsatisfied country. So this is the very idea, several scenarios, whom we allocate, for instance, first to USA, everything first to USA, this one scenario, second scenario to Russia, etc., etc. And these are the results, how to allocate, and by different scenarios. You will see now. You can see here, we have here even China and the Republic of Korea. These are other scenarios, and this is total satisfaction level. Total satisfaction level in all scenarios, as you can imagine, is negative. Okay. China and got in all scenarios 0 because of these 4,000 miles. South Korea also, but generally everything is allocated among these northern countries, so-called Arctic countries, and these are the number of territories of these areas allocated among these very countries. Okay, so you can see here 9,000 plus territories allocated in different ways in different scenarios. Again, I would like to emphasize, and this is very important, that the very idea is the distance. And after 4,000 miles, we don't consider that countries have some interest to these very regions. Okay? So another thing which we also started to we study also was shared allocation. For instance, our country, two countries make a discussion and make an agreement that they take together some piece of territory, this area, they excavate this gas and oil or fish or whatever together. and then somehow split the profit. So we can allow shared allocation. And this is the number of shared areas. You can see here how areas are again distributed with the same story. You see again, this very distance restriction, the distance limitation is still alive. And we can see here that the unsatisfaction goes to almost 3 times less. You see, when we have this very shared allocation. Sorry. Another thing which we did, unfortunately, I don't have here, I didn't include it in this presentation. We also used this adjusted winner by Steve Brum's model of adjusted winners. We applied it to here, but as you remember, adjusted winner needs always 2 participants, and so we did the following. We split first this all countries to 2 groups and make a division, this allocation between 2 groups. Then inside groups, we again, you see, after we got this result for a group, we did some split. We split this group into 2, again split among these 2 subgroups, among 2 subgroups, etc., and came to the result. It was really very interesting. It allows to decrease a bit dissatisfaction, but not very much. And here I finish my talk, almost finished my talk about this very allocation model. And I would like to emphasize several important things. The first part of the story is the following. We do not, again, make an allocation of territories. This is not our business. We are mathematicians, but what we do, we propose a model which might resolve the problem completely. You see, first of all, it is open to some new parameters. All kind of parameters of this very model are open, and tomorrow, if United Nations, after some discussions, will tell us, for instance, do not consider 200-mile zone as exclusive economic zone, but only 150 miles, it is possible to change it. Do not consider 4,000 miles as the most distant point where the utilities are still, there are utilities of countries. Took it 10,000 miles, it is possible to do it, and in this case, even Australia might get something, you see. So the model is open with, again, as I would like to emphasize, for new parameters, for everything, you see. So it might really certainly decrease a lot this very tension which really might happen. And I would like to tell you a story. You see, not last year, in 2020, at the end of 2020, because of the pandemic, the consumption of oil declined crucially, yes? At that very moment, United States said that we are going to start the excavation to start to work on this oil minings in Arctic. Immediately next day, Russia also said that we also will start to work on these oil fields in Arctic. I would like to again to say that it was in 2020 when the consumption of oil declined crucially. You see, there were no some extra need to excavate new oil, etc., etc. You see, it's a pure political stories, and countries are looking very much nervously on these very activities there. So this very model might really help to make some this kind of let's say tension or realization of interests much more mild, you see. Let me tell you in that way. And another thing which was very interesting, I asked my students to do the following. It was known that there were some kind of tension between Norway and Russia in the allocation of this border between two countries in the Arctic. And I asked them just collect all this data and use the model to understand what is the best solution. After a week of work, they came to me and said that, and as I told you, in 2010 was the agreement between Norway and Russia which resolved all problems, okay? And they came to me, my students, and said that, look, this very agreement and our solution coincide on 98.7%. Can you imagine? Almost 100%. After that, in a few months, I gave a plenary talk in some Arctic Congress and told that diplomats are absolutely great. They did this very split between Norway and Russia with 98.5% of accuracy, I mean, in terms of this very model. The question from the audience, do you know how long these very talks pass? How long there were these talks? I said, no idea. Answer from the audience, 42 years. I was a bit shocked, but I decided that maybe it's a joke or something and did not discuss it. And when I came back, excuse me, can you hear me?
Yes.
Yes, of course.
Yeah, and I came back home and checked it, and it turned out it was really 42 years of talks. Can you imagine? My first idea was that it is not a very good joke, you see, 42 years of talks. It turned out it's really 40, and this was, our solution was obtained in 1 week. About 5 days they collected data, and for a few hours, computer gave us an answer. This very 1.5%, you see, I know there might be in the talks might be most important part of the story because the question was about the passages of submarines, you see. But we didn't go to this very details because first of all, we did not have data, and I didn't like to go to this very part of the story. Okay, and then we look at this availability, as I told you, gas and stuff in Barents Sea, and then this very idea about allocation of this between countries. And the other question, if you have questions concerning this first part of my story, now I go to the second part of the story. No
Yeah,
question.
Fuad, yeah,
Yes, please.
could I ask you a little bit about the countries you included? Because you included China, South Korea, Japan, but you don't include Sweden and Finland. I realize that they don't have they don't border on the Arctic Ocean, but they're countries that have regions above the Arctic Circle. And how are you measuring distances?
The distances we measured absolutely in a straight line. You see, not by straights, etc. No, just straight. You see, again, this is, you see, it is not a problem at all to include there all these countries like Sweden, like Finland, or measure these distances by straits, by sea roads, etc. You see, it's not a problem. This was just, if you wish, exercise to understand how it works in general. You see, and China and Japan and South Korea were included for the following reasons. They have really very serious interests in Arctic. For instance, South Korea, more than more than 10 years, they organize their laboratories for scientific study of northern ecology, etc., etc. The same as Japan. About China, I don't know about 10 years old story, but now they also are very active in, China is also very active in northern seas. You see, in terms of organizing this very laboratories, etc., etc. Okay, did I respond? You got it? Yes.
Yeah, thank you.
So, other questions, please?
Yeah, can I ask you the shared allocations?
Yes, please.
That seem to work so well. There must be some. What is it that binds the different countries doing the sharing to not wanting more than their share? I mean, why do they work so well? There must be some mechanism there.
Yeah, very good. You see, very good question. You see, we in fact considered shared allocation of countries absolutely arbitrary, but due to this very idea of shared allocation, naturally, you see, the interests were, you see, of maybe opposing countries, for instance. You see, I'm far away from this area. You got it, but I can join you, and this will decrease this very dissatisfaction level. But again, you see, we can add here very easily, for instance, that shared allocation might be only in neighboring countries, for instance, okay? Then naturally things will change. So it is not a problem, you see, to evaluate it. Again, as I said, my idea was to show how this mechanism works. And if, again, United Nations will say that here you should consider only neighboring countries, it's not a problem at all. You see, it's in 5 minutes we can change the program.
But what enforces the shares?
What enforces?
Yeah.
This is just.
Why doesn't the country try and take more than its share?
No, this is the idea is very simple. You see, if you have this part of the story and I'm very dissatisfied, maybe you will lose your satisfaction, but I will be much more satisfied with sharing with you this idea, you see, and in total, dissatisfaction level will decrease. That is the story behind.
Okay, I have a question for
a
problem actually. I mean, this distance is a nice concept, and if it's widely accepted or is accepted in the world, you can apply your model. But when I look in history, actually, distance did not matter too much. When you think about 1492, the Spanish went to the west, the Portuguese went to the east, and so long distances. And then the Dutch came around, long distances. And, there could be a country, Italy. Now, Italy is definitely not the country we think of, but Italy could say, well, I want to have a share there in the Arctic. Well, then you would say, well, you're very far away, but they could say, well, does it matter? You see,
Yeah, I understand.
That's a problem for me,
Yeah, I understand your point very well. You see, again, in this very case, for instance, there might be another approach. 30% of this very reserves of oil and gas are in Arctic, okay? United Nations might create a rule that these very reserves should be split, for instance, equally between countries, with a bit more giving to the countries which are in the Arctic zone, for instance. Again, we can immediately change the model and take it into account everything. Then this distance does not matter, but what will matter, the share of these allocated resources. Then Italy naturally will get some parts, etc. That is, you see, this is the simplest model which I constructed in terms of this, to understand how this mechanism might work. After that, we can play a lot of things with this very model, and naturally, if there will be some, let's say, strong interest around, well, everything might be adjusted. The only thing I told students, you see, when I look at the results, look at this very allocation of these very resources of gas and oil, I told students, I gave it in one lecture of decision analysis, I told students that, in fact, you see, I dream that Arctic seas will be frozen for 500 years more, because I really, you see, especially now because of the global warming, I really worry about that tensions might easily be converted to real, some kind of, you see, attacks, etc., etc. You see, maybe we need 500 years more to become more clever. I don't know. Well,
yeah. No, I hope that at least there's an agreement on distances. I hope so in a way, because then you can do your model, you can propose this, you can propose that, and then it's more, then there's some hope, that there will kind of agreement. But once you ask, why should distance matter, things are getting much more tough, much more complicated. But it could also be that distance might work, because when you look at this area, I mean, there's the US is there, there's Canada there, China is not too far away in a way. You could model it in a way that it gets into it, and there's of course Russia, so there are very powerful countries there, military, economic wise, I mean, there is no Malta around, so maybe that's a reason why your model could quite well function in a way. But that's just a hypothesis, of course.
Might be. Thank you very much. You see, the only thing that what I do know, I would expect that, for instance, if tomorrow, for instance, there will be a decision that all countries might pretend to get something, these very superpowers like USA, China, etc., would say that why countries from South America should pretend to this territory? They are too far away. You understand?
Yeah.
Or Australia. So it is necessary to come to some decision. And maybe United Nations will come to the decision that split it equally, because Arctic is really, you see, the thing which belongs to all mankind, not to these countries which are around. If they accept it, well, again, it is nothing. We don't have here any problem, you see, to re-evaluate the situation.
Okay, thank you.
Can I, Fuad, you mentioned global warming.
Yeah.
And I think COP26 and 27 next year might say that the best thing to do is to leave all the oil and gas exactly where it is, so that the share to everybody would be zero. I take Manfred's point about history, and the scramble for Africa was not very nice, and the scramble for China, which followed it, was not very nice either. And historically, the chances of cooperation are not good.
Not good. Definitely.
But because of that global warming or global heating, would not the best answer be to allocate maritime resources, perhaps? Fish, well, maybe, but not oil or gas.
Let me tell you in that way. You see, you might be right, you see, but the story is the following. Let me tell you in that way. Because of the global warming, for instance, 30 years ago, 40 years ago, because of the situation in the Arctic, nobody would even think about to excavate oil there, because you see all these platforms, sea platforms, will be very vulnerable to ice moving, etc., etc. You see, it would be absolutely crazy idea to excavate oil. Now the oil is melting, you see. Sorry, not oil, ice. And we have more and more open seas without ice, you see. And I will talk about it later, about even now there are, let's say, suggestions that in Arctic, there is a United Nations rule of, I don't know, something like 54 or 60 years ago, it was accepted that only the vessels with special protection, how it's called in English, special protection of their from ice, they can go to the Arctic seas, you see. And can you imagine now some countries says that because the oil, ice is melted, why not to allow usual ships, usual vessels to go, especially we talk about tankers, and you will see the results. Why not to allow tankers to go without this additional protection? You understand what is going on? For me, it is, you see, how can I say this? Ecological problems might overturn everything, you see, all kind of profit which countries will get from this very excavation of oil and gas. Hopefully not. I don't know. Well, okay. Some other questions? I go to the next part of the story. And next part of the story was the following. The very idea, the second part of the story came from this very idea, from this very suggestion. Sorry, Manfred, how much time do I have?
Well, I would say another 20 minutes. But
okay. Okay,
That's
no.
just a talk. If you take 25.
Okay, no problem. I will finish even earlier because I thought that maybe 3 minutes, then maybe not.
No, because we had a discussion in between, it shouldn't be your time,
Okay. Okay. So the idea was the following, you see, due to these very ideas on to allow these very vessels without additional protection to go to the Arctic seas, my idea was to evaluate what do we have in case of potential oil spills. In fact, I did some work first my work on this was in '86 for ecological problems for Yaroslavl region. And after that, I was invited at first time it was published in '86. And after that, I was invited to be a United Nations expert in the spread of these very pollutions. And I constructed a model. You see, at that time, my idea was, and many people were working on this, to construct the partial differential equation systems of partial differential equations. And then after analyzing these systems, I understood that, you see, we have a pollution, but the evaluation by the system of partial differential equations might take hours or maybe days to evaluate, although pollution will be gone already, you see. So my idea was to evaluate this in a very robust, approximate form, but to do it very, very fast. And then I constructed the model, and which was used here, and I asked to another my student to collect data not about white bears, but about these whales, narwhals, and I forgot how it is in English, the third one. And what we did, we made different scenarios of the oil spills spread from tankers, for instance, or excavation point, with 350,000 barrels of oil, you see, which more than 10 times less than which we had it in Mexican Gulf. We considered 3 scenarios, and let me tell you a few words about that. This very model takes into account the currents, the flows, the ice, you see how it works from the point, the ice fields, how it stops this, and even the density of oil, you see, because heavy oil very often goes to the bottom, you see, but light oil spreads around. It is possible also to use this, and all these evaluations goes very, very fast. That was a very idea to, in case we have these oil spills, to evaluate very fast where they go, taking it into account, as I said, wind, currents, and ice. And these are three scenarios. The first one, we consider oil spill in the Svalbard region. Narwhals, these are animals from sea. So much narwhals will die. Walrus so much, and white whale. First, what we did, we collected data. There is a rather good data collected by biologists about spread of this all kind of fauna over Arctic seas, you see. And when we see this very amount of oil due to these currents, etc., goes in that way, how many animals, how many these very animals will be hurt? In fact, we have this very evaluation for about 12 different types of fauna. I even myself did not see these white bears, because you see, for me it will be too painful to see the results that so much white bears will die. Okay. Another model was, another scenario was near Greenland, you see. So we see here narwhals will die from 20 to, it depends why, from 20 to 2,400 because of the wind direction and currents direction. Walruses over here, and white whale, look here, up to 16,000 might be. And the third scenario was in Chukchi Sea, that is at the far east, near this place where Russia and United States come together, Alaska. There are no narwhals there, it is zero. Walrus is, you can see, it's from 300 to 3,000, and white whale from 20 to 13,000. And this was, again, you see, if we come back to this very models, which this makes me absolutely certain, about the following. Before we start excavation of oil and gas there and use tankers to move back and forth, we have to create special early protection and early information system. You see, if something happens, and this is absolutely accidental thing, you understand, we have to react properly, not to wait. In Mexican Gulf, they said that British Petroleum spent $4 billion and cleaned up this Mexican Gulf. I haven't been there after this events, so I don't know, do they really clean everything or not? But here in the North Seas, $4 billion will not be enough to clean it up, you see, if it goes absolutely without any specific information and protection system. We have to create some kind of teams, some kind of special equipment, etc., that if something happens, immediately stop it somehow to spread and then to collect this oil, etc., etc. Otherwise, because of the ice, because of the winds, etc., this will not be cleaned by $4 billion. It will be much more serious. We apply this very model also, one of my students applied this very model also to the Mediterranean. Maybe you know that Turkey found oil near its borders between Cyprus and Turkey borders. And they said that they are going to excavate this oil. And our evaluations show that in case of these oil spills, they might go up to even Africa, you see. If it is not, it will not be somehow prevented beforehand, you see, I mean, in proper time. Or we consider also different scenarios, and this oil spill might go to Greece, or even to Italy, in the direction of Italy. Here is the same, you see, we can consider it, and depending on what is important here, that you see this system might work very fast. You see, we shouldn't evaluate all these kind of, you see, systems of differential equations, of partial differential equations, and wait for days when they get to the answer. Rather, taking into account these flows, these currents, these winds, etc., we immediately can understand how it will go further, and then to react somehow to this very disaster. Okay, and we now started another thing, you see. Let me finish it with a joke. 2 years ago, or 3 years already maybe, because of this pandemic, vice rector told me that rector said that there will be conference in the north, in the above polar circle somewhere, I don't remember, in winter, in January, and he said that rector would like you to go there to learn all these things, etc. I said that, you see how stupid was this decision. I am from south and decided to work about the north. How great it might be to work about Mediterranean, Pacific, etc., rather than to the north, but still I proceed, and one of these very new results, we started now to work on migration problems, but this will be maybe next my talk in, I don't know, half a year, because it is also another very serious problem of Arctic. Thank you very much, and thank you very much indeed for inviting me here.
Yeah, thank you very much, Fuad. I don't know where the microphone is on. Can you hear me?
Yes, yes, I can hear you.
Oh,
and,
wonderful.
And Manfred, I can answer before Nicola will start. Maybe there are some questions about this part of the story about ecology. Yeah. I'm ready to answer.
Yeah, that's what I wanted to say. Yeah. Questions? Basically about the ecological problem, you talked about the last 10 minutes, so to say. I mean, yeah.
I cannot hear you very well, Manfred. I cannot hear you very well because there is some sound there. Can you repeat your question or what you said again?
No, it was not a question. I was just kind of commenting, you know, that if this polar circle region should be used, then of course you might differentiate whether you use it for traffic only, whether you use it only for fishing, or whether you do everything like oil and gas, you know, because then the environmental problems are different, you know, depending what you do. I mean, even for shipping, you know, it could be a catastrophe if you do it there, because the usual impacts, you know, I mean, the fauna and flora and so is rather, flora is hardly any there, you know, for cleaning the water, or I don't know it really, but it's a very complicated environment, you know.
Absolutely.
So are there questions now? I just wanted to breathe a little bit, you know.
I should like to ask a question, may I, Manfred?
Yeah, of course, Heinz.
Yes.
Go ahead.
Now, I was wondering when I looked at your numbers concerning animals that were affected by the oil spills. I mean, what is the time horizon? How long does it take?
Yeah, that is sorry. Good question.
And of course, I mean, in some cases where the losses are tremendous, you might reach the threshold level below which they will die out because they don't find sexual partners and so on and so forth. I just wonder, I mean, did you use a growth function, a recreation function of those animals in your calculations?
No, let me tell you in that way. You see, it was yeah. Thank you very much. I forgot to tell you about. This is these very values are about. We did it in several iterations. It is about generally. It's about in 8 days. Okay. In 8 days, how it will split depending again on currents, on winds, etc. Or we can also consider, in fact, it works very fast. We can consider longer period. This is really, you see, the situation. You are absolutely right. And we consider it in a very simple way. You see, there is a place where these walruses, for instance, are living. Okay. It is covered by oil. Okay. And they die. That was the story. In fact, these very small amounts which we consider because they are living in different places, one such case will not destroy whole population, but it will be disastrous. You see, in the first one, oops, sorry, here, narwhals in Svalbard region, it might kill about 1/4 of population, of total population of these very animals. And we can evaluate this kind of things. For me, you see, let me tell you in that way, you see, for me, it is very, very depressive. Depressive because of the following, you see, I always look at these numbers and understand that if people do not come to some kind of agreement how to develop all this stuff in the best way, the results might be really disastrous. And that was the reason why I didn't allow them to evaluate about white bears, you see. To look how many of them will die, you see, will be too painful. Although we have all data, etc.
Some more questions? Yeah, we had our discussion already, you know, with this, so to say, the tougher part of the model, you know. Now we are more thinking about these catastrophes. And, well, with the catastrophes and the pollution and the heating, and I think there's not too much to discuss, really, you know. That's more to think about, you know. So thank you very much, Fuad.
Actually, before we quit, before we quit, can I just say something?
Sure, John, yes, great.
It's not particularly about the talk, but something that Fuad said before he started talking about coming to the U.S. for the first time in 1985, which is when I met him. And we really owe Charlie Plott a great deal of credit, because he was the one that got Mark Eiserman and some of his group from the Institute of Control Sciences, like Fuad, to come to Caltech for an extended period, brought people in to meet them, and also started including their papers in the Caltech Working Paper Series, which is how their work really got known. And it's been great to be friends with him since '85, so it's a long time. And it's nice to see him again.
Yeah, nice to see you, John, also.
Yeah. Is this little Donsari there? You know Donsari? Because
sure.
Well, he's at UC Irvine.
Yeah, I know Donsari, and I know him very well, but I don't remember that Donsari at that time was in Caltech.
No. Don was in mathematics at Northwestern.
Because he used to work on problems of allocation of the northern hemisphere, so to say. I think 20 years ago. That's why I thought, yeah.
That's interesting. I will send him these results. Yeah. Maybe he will respond somehow. We
Okay.
sometimes we exchange letters, but yeah, I consider this very thing rather more technical, let's say. But what is important, what you said, Manfred, and from my point of view, what is important here, again, you see, these kind of things should be understood. And maybe you see, really it will be the case when the United Nations or some other organizations said that, look, before you start this excavation of oils, construct this early warning system, for instance. That will be, from my point of view, most important thing, you see, not to think about the disasters afterwards, beforehand.
Okay. Okay. Thank you very much. So, yeah, then of course, special thanks to Nicola, and thanks to Fuad and to everybody who contributed by thinking, talking here, and listening. Okay, thank you. That was our session.
Thank you very much.
Thanks to you. Goodbye.
Bye-bye.
Bye now.
Bye-bye. Thank you very, very much.
Bye-bye.
Goodbye.
It was great to see you all. Thank you.
Yeah.